You can see South Africa is located here, quite far south, but also you can see here is the equator. It's not definitely tropical, but it still has quite a nice warm climate. But in winter things can still get quite chilly, and again, different areas of migration. There's a couple of groups of birds that migrate just a little bit up, or a little bit is of course relative, and they migrate towards the tropical areas in Africa, and there they can find all the food that they need to have. There are also other birds and those are probably birds that didn't originate here but started migrating here long ago. They actually breed all the way up in the northern tundras and in the Arctic regions. And twice a year when winter comes there and summer arrives in South Africa, a lot of them actually travel all the way from almost the North Pole, all the way sometimes to South Africa. And some birds actually, it's amazing feats. We always, if you think about migration, sometimes we think about the wildebeest migration in the Masai Mara and the Serengeti, which is a beautiful spectacle to uphold, but as far as performance and achievement is concerned, it's nothing compared to bird migrations. Let me just give you a quick couple of examples. If you have the Arctic tern, which actually migrates about 50,000 kilometers a year, it lives, part of the year it lives at the North Pole, Greenland, the Arctic tundras here, and during the year it goes all the way here, all the way here, all the way to Antarctica, lives there for other part of the year, and then 6 months later goes back again. It's a trip of about, every year travels about 50,000 kilometers. In its lifetime it might do 1 million kilometers of migration. That's quite impressive. Where's my mouse now? I have to go to the other side of the map, but it goes this way basically. And it comes out here all the way to New Zealand. That's a journey of 11,000 kilometers, and it does it in 6 days non-stop. It doesn't stop to rest or anything. It just leaves Alaska, keeps flying all the way until it gets to New Zealand. That's 6 days non-stop flying, about 80 kilometers per hour. That's just for a bird that's the size of maybe let's say chicken-sized bird. It's very impressive. So why expend all those, all that energy? So it's about food source. It's about link to food source. If you're healthy and you have enough food, you can raise more chicks, which means your bloodline is actually going to be more successful, and that is why birds migrate. But now the question is, that's all fair and nice. Yeah, birds migrate. They fly from here to there, but how do they migrate? How do they prepare for migration? And how do they actually manage to fly these 11,000 kilometers in 6 days or 50,000 kilometers a year? Because that's not a fairly easy thing to do. You need to adapt, to be perfectly adapted to that lifestyle. So the first thing that a lot of birds do, they have physical adaptations, and that goes quite far. It depends a bit on whether they're small birds or big birds. But one thing that a lot of, especially the smaller, the waders, the shorebirds do, is something that's called hyperphagia. And exactly remembering that term is not important, but it means overeating. And what they do is, just a month before the migration starts, they start actually eating and feeding themselves. And that way they can actually increase their body weight by about 50 to 60% sometimes. And all that excess body weight is stored as fat. And you might think, oh, that's maybe not good, because fat, we always have negative connotations with that as humans. But fat is a very efficient energy storage. It contains per amount of weight, it can store as 5 times as much energy as, for instance, proteins. So it's a very good way of storing excess energy. Unless as humans, if you want to get rid of some extra weight, then you need to expend a lot of energy to get rid of a couple of grams of extra weight on your body. But for birds it's very good. And so with this hyperphagia, they eat and they eat and they eat and they eat. And then once they start flying, actually some physical changes take place inside their bodies. Some of their organs actually shrink or are partly reabsorbed into the body, because during the flight time they are not needed. Like the liver gets smaller and some other digestive parts get smaller, and that saves on weight during their flight. Also, if you look at, for instance, the wing shape of migratory birds, they are more geared towards, they're thinner and longer, as opposed to sedentary birds, which means that they are more geared towards long flying with low energy. And another special adaptation that as far as I know is only seen in birds, is that they actually have two types of hemoglobin. Hemoglobin is the part in your blood, the component that actually transports oxygen. And they have one normal type, so to say, which they use during every day. But there's also a special hemoglobin type that is especially useful at high altitudes, because it has it can transport oxygen more efficiently if there are low oxygen levels about. So, whereas humans, if we have to perform on higher levels, we have to first adapt to the higher levels, so we get more, I believe it's red blood particles in our blood. It takes time. For birds, that's immediate. As soon as they fly off, the other part of hemoglobin kicks in, and they can still get enough oxygen to their muscles while they're flying at high altitudes. So there's a lot of physical adaptation that goes on with regards to actually even the preparation for the flight. Not all birds gain that much weight. It's the smaller birds, especially the waders, gain that much weight. And the reason for that is, again, if you think about it, comes down to food availability. Waders have a very specific habitat in which they need to feed, which is a small strip along the coastline between land and water, which is not available everywhere. So along that journey there will be long stretches where it will not be possible for them to feed properly. So that's why they have to have huge energy stores, so they can go long distances, and it's typically what they do. They fly a long distance, maybe somewhere from here to the northern part of Africa, and then their energy reserves are used up, and then they stay there for a couple of weeks, feed again, then do this hyperphagia thing, and then they fly the next lap. So they take a couple of steps along the way. A lot of the bigger birds, like some birds of prey, like the steppe buzzard, they also migrate, but they just fly a couple of hours per day, and then they hunt for prey along the route, so they can eat regularly. And while they also gain weight before they fly off on their migration, it's maybe in the order of 10 or 20%. So, but definitely not as much as the waders do. So again, all these adaptations are adaptations to how can you deal with your food source and make sure that at every point during the journey that you can reach the place where you can eat next. That is actually what it all comes down to. And then again, travel mode. It's one thing, you have energy stored in fat or in other places, but then the second part of the equation is, of course, to use your energy as efficiently as possible. So that is what birds do. That is a very known phenomenon that we can see is they fly in a V shape. Even I know in Holland, if you see the geese flying in V shapes, then we know that winter is coming because they start to migrate. And I'm sure that's the same in a lot of other areas. The second thing is about how do you fly? If you can imagine that flapping your wings the whole time is very energy consuming. So there are also a lot of birds that actually use what is called bounding flight. They flap their wings for a little bit, maybe gain some altitude, and then they keep their wings outstretched, and then they actually sail or glide for a little bit, and then they bound again. So they actually on the air they can actually fly a little bit, rest a little bit, fly a little bit, rest a little bit, and that also helps in conserving energy. And then, especially for the bigger birds, they also a lot. They use the thermals a lot. Like for instance, the storks. They only start later in the morning with the flights. When the earth starts heating up and the air starts moving up, then you create thermals. And the storks, for instance, they use these thermals to gain altitude, and then again they can sail for long distances with expending very little energy until they find the next thermal, and then they fly up again, and then they go further.